Right then, I think we're going. Good afternoon, anybody who's decided to join this live stream. I hope you'll find something of interest here. For those who are not aware, this is part of the week-long celebrations accumulating in today the efforts of the Consett Steel group and Project Genesis and many other people to celebrate and remember the closure of Consett Steel 40 years ago today. Over the years, being a citizen of Consett myself, I've been pretty fascinated with its industrial history. And as a bit of an IT nut, I've done a lot of work with mapping and GIS and digital technologies such as Google Earth. And some of you may have seen some of my work online already, showing models of the steelworks and maps and such like. In this quick session today, I'm going to give you a very, very brief overview as to how those models and those maps came to life. Now, this won't be an in-depth session because, quite honestly, if it was, it would take an entire day for me to show you all the little itty-bitty details. So it's going to be a fairly quick overview. I'm going to introduce you to the tools. I'm going to show you some of the things, some of the challenges that had to be overcome in order to make this happen. And hopefully you will, once you've watched this, want to get involved in helping add more and more to this map and make it available for future generations to understand exactly what used to stand where there is now new houses and large areas of open green space. So without further ado, I'd just like to thank the History of Consett Steelworks Group for inviting me to do this presentation for them. Thank you, Richard, and I look forward to collaborating more in the future. Right. Now, getting started with digital mapping comes from having a good source of maps. You can search very easily in Google or Bing and find many sources of old maps dotted all over the internet. Two of the most well known are probably oldmaps.co.uk. On here you can put in any town or any place you wish to know the map for, and then down the side of the display you will get a range of old maps of varying dates. Now you'll also see that many of these maps have scales on them. The one in 2500 and the one in 10,000, no sorry, not the one in 10,000, the one in 2500 and the one, there is another set of, the one in 1250, sorry, not the 10,000s, are usually the ones that you want to be looking for. And generally, when you get a good map that has pretty good resolution, you want to be looking at something like this. Now, some of these maps don't have everything on them. Some of them are mixed matches of older and newer maps where they've had to combine them together. But they nearly all will be available like this as a raster map. Unfortunately, with oldmaps.co.uk, they do want you to have a membership, a paid membership, in order to zoom in too far and export the maps and things like that. And actually getting these maps off the web onto your PC is not something we can cover in this session, because there are a multitude of ways, and well, there are just lots of ways of making it happen. So, once we have a good source of maps, something like the National Library of Scotland, for example, I think we have one already open. Yes, we do. So, once we have a good source of maps, we'll take this little snippet of Benfield side here. Then what you're going to need is you're going to need some mapping software. Now, traditionally, mapping software used to cost a lot of money. Projects like ArcGIS and other such software, Autodesk Map 3D, for example, can cost many thousands of pounds. In recent years, however, there is a new contender on the block, and this is actually a free application that any of you can go and download anytime right now. They do ask if you want to support them by giving a donation, but you don't have to. And this software is actually very, very easy to use. It comes as a Windows application. You install it on your Windows desktop. It is cross-platform, so those of you who prefer to use Linux and Macintosh, you can put it on there as well. And this kind of software makes it ridiculously easy to take these static map images that you've downloaded and then turn them into something that you can use to do more advanced things with. So just to give you an example, if we get that out the road and I bring up my copy of QGIS, you can see here I've got my Consett map loaded in. Now, right now, I've done quite a lot of work on this, but as you can see, it's far from complete. The green layer are the normal buildings. The purple layer are railway buildings, the orange layer are company buildings, and the blue lines are the railway tracks that used to run in, around and through the town. As you can see, there is a lot of work still to be done on the green building layer, and I'm sure if I zoomed in and panned around enough I would find some of the smaller company buildings that I've missed. And of course, if we go over here towards Lead Gate, we have places like the Bradley Engineering Workshops that would need finishing off. We have Leadgate Railway Station, which would be over here somewhere, that would need putting in. So there's a huge amount to do. Getting a good map is as much of an art form as it is in drawing on it. And to actually get a good map, we need to use something called a geocoder. Now, I don't actually have time to go fully into that at the moment, but for example, if I bring up this snippet of Bensfield side that I just downloaded a moment ago, what we would do typically is we would load this image into this application, and then we would use a known source of existing mapping from something like the Ordnance Survey, which the Ordnance Survey do provide some free products, by the way. I'm using something called Master Map, which is a paid for product, but there are products that can be used free as well. And typically what we would do is we would bring in some modern day mapping such as this. Now, if we just browse ourselves over to this same location, what you would then do is you would use the tools built into QGIS here, and you would match points on this map with points on this image. So for example, I would register a point there on the corner of Ritterson Street with a digital point here. I would register a point there on the junction of King's Road with a picture point here. And likewise, I would register anything that still exists on the modern map and is visible on the old map. Now, this presents a problem if the map that you're wanting to convert only has old stuff on and there is no old stuff on your newer map. What you typically then have to do is to take a larger area. This it only draws at certain zooms, sorry. You would then have to take a larger area so that you have area around the map that you're trying to reference, and so that that area, while it may not have any matching stuff on the newer map, has points out here near the edge that you can match to it. The net result, once all this is done, is you end up with a map like this. So this map that you're looking at here, this is the 1970s map for Consett. You can see there's Black Hill Railway Station, the original Black Hill Tunnel, and then as we scroll down this way we come into number 2 plant, number 1 plant, and the general offices, the power station and such like. Once you have a 2D map like this, putting the rest in becomes much easier. So as an example, let's find, we'll do most of our work with this building here. I've no idea what it was, because I'm of the age where I was old enough to remember the steelworks just before it closed, but I never actually got to work there or go inside of the place. All I got was to see them tearing it down, and as a teenager run right up and down the railway lines and play in the old abandoned structures and such like. Now, I'm just going to add a temporary layer here for a moment, so that I don't damage anything that I already have. So we'll call that temp, and we'll make this a polygon. Now, this value here is an important one. All maps have what's called an EPSG code. If you're using a GPS device or something on your phone, you might be used to putting a point on a map and walking around and following it. That will use this one here, known as WGS84, Worldwide Latitude and Longitude. When you're working with local maps, such as the type we are here, you're always going to want to see if you have a local coordinate system. In our case, for the UK, it's always going to be EPSG 27700 or OSG B36, as it's more commonly known. And the reason for this is because when you use the worldwide coordinate system, near the poles and the curvature of the Earth, because it has to cover such a large area, you'll get differences, you'll get stretch, and you'll get inaccuracies in the mapping and the maths that are used to calculate it. So we need to make sure that we're including the right one here. Once we have a layer, you can store that layer in a file, you can store that layer in a database, you can store it in a spreadsheet. There's lots of different ways. I'm not going to go into that in any detail, because that is not the aim of this session. The aim of this session is to show you how the maps and the models were created, and not actually the technology behind them. So we have a layer, and we're now going to put this layer into edit mode. So we'll just toggle that in. Now you'll see when I put it into edit mode, a number of these tools over here all light up. I apologise if I'm a bit ham-fisted with this, but this is quite a low resolution with me presenting it to YouTube. Normally I have a much larger screen area, so you can see some of these things are folded down, such as here for example. But you'll see a number of these extra tools line up. And these tools all allow me to draw modern day digital representations of things over the top of this map. This map will also help me in drawing these things by making sure that corners are square and things are straight and they match up quite parallel, which is important for the later stages, because once we start loading these into other applications and turning them actually into something substantial, then we find that having straight corners and straight edges and everything square is a real advantage. So let's make a rectangle for this here. We'll choose our rectangle tool and we'll add a rectangle from 3 points. Different tools can be used for different purposes. The rectangle from 3 points is usually the best one to use if you're doing a rectangle that's not straight on a north or east axis, because it allows you to go along one wall of the structure and then stretch out over that structure. Right click and there we go. That's now been created. Now if I untick that map from underneath, you'll see that we're left with that rectangle there. But importantly, and this is where this whole geocoding thing comes in, by matching a map to points on the map using another known map. If I move over a corner of this, you'll see where that little purple marker up there appears. If you look down here at the coordinates, you'll see that they're actually quite strange numbers. Now if you've done any kind of work with any kind of images or pictures on a computer, you might be used to them starting in the top corner at 0 and ending in the bottom right corner at whatever the width and the height of the image is. And it's this reason that we have to match these coordinates, because those coordinates of the images get mapped to the coordinates in the real world on the map by this geocoding process. If you don't do that, then your resulting line work that you've spent many hours sitting drawing doesn't appear in the right place on other maps, it doesn't appear in the right place on Google Earth, and it certainly doesn't appear in the right place when you start wanting to take that 2D work and turn it into something more substantial. There are ways and means around it, but certainly it's much easier if it's geocoded. Now, I can continue adding stuff to this. So let's add a couple more things in just to demonstrate that this actually works. So this rectangle here has got a little bit of a dog leg on. So what we'll do here is we'll use our rectangle tool again, and we'll cover the entire structure. But what we'll do now is we'll go into the properties for this and we'll bring its transparency down to about half. Now by doing this, this allows us to see through our line work. So you can see now that I can still see the map behind that. And that means I can now use tools such as the cut tool here to clip out bits that I don't need. So you can see that given time and patience, we can build up lots and lots of different pieces of line work. And putting chimneys and things in is just as easy as well. So we have a chimney here. We'll take a circle from 2 points tool. Sorry, I'll try that again. If you make a mistake while you're doing this, pressing escape on your keyboard will abandon everything. So you can start again. And you'll see using the circle from 2 points, we can put a chimney there. Yep. And again, if we just remove this mapping now, we'll see that this is all left behind. Right, okay, so that's the 2D mapping. Over the years, as I've already shown here, if I click on this company building layer, you can see that I've done all the line work to get most of the buildings in. So we have the engineering, the railway engineering place that used to be over at Black Hill. We have the Black Hill Tin Mills, we have the bottom end of number 2 plant. I'm not entirely sure what that building was there at the bottom of the Canyon Road. Nor am I in any way familiar with what was actually done in any of these buildings. I just know they're more common names. We have number 2 plant going all the way towards the Grove there. And we have the original company offices here. All of this is gone. And the reason for recreating this is so that we can locate them properly. The normal building layers, you'll notice as well that I have all these in different layers as well, so that I can work on individual parts at a time. I can switch off the company buildings, and I can take the other line work that we've got here. And in time, what we will do, or what I will continue to do, and anybody who wishes to get involved in this project, is we will take these existing sort of structure, this existing map that we have, and as a combined effort, we'll continue to add buildings to this, which can then be used by other people in the future to point to things that are no longer there and help school children of the area understand what we used to have. Once you've finished with your features, if you're saving these into a database or into a file or something, don't forget to hit your Save Features button. This is different from your Save File button. You can save your file and it might not necessarily save anything that you've edited. So always remember, save your features, take it out of editing mode, then save your file. That way you won't lose any work that you've done. If we move over here, it doesn't have to be rectangles and things. You can put line work on. This is how the railway lines have been done. They've been done using normal line tools. You can see when I go for the railway layer, for example, I get a different icon up here. I get lines rather than rectangles and circles and things like that. And in time, you will build up your own maps. Now, getting things into the 3D world is quite a challenge. There are many different applications and not all of them play nicely together. At one time, the easy route used to be drawing the 2D work in here in QGIS, then exporting it as a Google Earth file, and then using an old version of SketchUp called SketchUp 7, which knew how to read Google Maps. The beauty of using SketchUp 7 was that if I took this map here and overlaid it onto a Google Earth map and then used SketchUp to bring this map in, I would get that geo-referenced map appearing in SketchUp. Since Google sold SketchUp and it went to a company who was interested in making profit, this is no longer the case. An old version of SketchUp 8, if you can get hold of it, will still read Google Earth and will still allow you to locate things on Google Earth, but it will not allow you to put this base mapping in. Now, as a result, I can't actually show you, or I don't have time anyway, to show you how to take the line work from here and push it into SketchUp. So I've got some pre-made ones, which I'll show you in a little while once we've gone through some of the other options that we've got. However, with this modern day version of QGIS, this actually has 3D features built into it. So if I just go to View and New 3D Map View, we'll get this window here. Now, just to make things a little less cluttered, I'm going to move that 2D one off screen. We'll get rid of this as well, so that all we have is our 3D map. And you'll see that it's already started to draw the 3D map. That's based on just what I've got underneath, which is the Consett, the raster map. So if I zoom in a little bit on the town centre, for example, you'll see that it's still drawing, and it will continue to draw. It's not going to do a fully high-res drawing of it, purely and simply because it's 3D and it needs to try and sort of keep the processing power down. Now, just a word of warning here, once you start doing this 3D kind of stuff, you do need a PC that is going to have quite a little bit of clout. I've got quite a high-end graphics card in the PC that I'm using. Typically any PC that advertises itself as being a gaming PC is probably going to be up to the task. But it's like with anything, the better the graphics card, the more memory, the bigger the hard drive, the easier this is going to be for you. Now, if I put my green buildings layer back on, you'll see that's started to appear there. And you can see that it's redrawing the tiles and redrawing the line work. Sometimes it can take it a moment or two to redraw things, depending on how busy your PC is and what else is going on. You're always going to want to have one of these with you when you're doing work like this as well. It's an absolute must. There we go, loading 6 tiles, 5 tiles. It can be like watching paint dry sometimes. You have to have a lot of patience to do this kind of work. And there we go, it's finished drawing that. Now you might be thinking to yourself, well, this is still not 3D. We're still looking at pretty line drawings on a pretty 2D surface. If I hold down my middle mouse button and pull back, you'll see that it allows me to tilt my map like that. And again, it's loading its tiles in, it's recomposing the display. It'll take a little, there we go, it's done. Now, in order to turn the 3D on, you need to go into the properties for a layer. So if you remember previously, we brought this up to change the colour of our temporary layer. Just resize it a little bit, and we brought it up to change our opacity and things like that. If we bring this up again, we'll see that we have 3D view here. And if we turn on the enable 3D renderer, and we'll pick a nice green colour to match the colour of the 2D stuff that we have there, and we'll set its extrusion, I don't know, 7 meters, something like that, and click OK, and there we go. You'll see what will then happen is QGIS will actually pop our 2D line work out of the map, giving us a pseudo 3D view. Now obviously there's no detail in this because all you're drawing in QGIS when you're drawing on a map like this are simple 2D shapes. As I previously mentioned, we'll come back to how the detail is achieved in a little while. But right now, even without leaving this package, you can pan around over Consett. You can pan around over those objects that you've already drawn. And by using your middle button to spin around them like this, you can look at things from all sorts of different angles. Now, if you remember before, I highlighted the fact that I have different layers with different colours in. And this comes in somewhat handy when you're using the 3D view like this, because we know that the company buildings were much higher than the surrounding normal commercial buildings. So if we now re-enable our company land, our company buildings, our company layout, whatever you want to call it, and then do the same for that and turn its 3D view on, we'll pick an orangey colour so that it matches the underlying graphics. We can actually set the extrusion on this to be much higher than the other buildings. So if you remember, we set the green buildings to 7. Let's set the company buildings to something like 20. And you can see now straight away that this gives you a really, really, really good idea of how big, how absolutely massive those buildings were in comparison to the surrounding buildings. Now, those of you who were sharp-eyed may have spotted a few problems here. For example, if we come over here, you'll see that number 1 plant hasn't been drawn in. And I think if I remember rightfully from when I was looking at this the other day, the plate mills didn't draw either. Or no, sorry, the plate mills didn't draw, but just to make sure it was all working, I actually recreated them. Now, going back to what I was on about before, when I created that temporary building and having straight corners and straight sides and having the mapping application helping you, this is where it becomes important, because the reason this hasn't popped up with the rest of them is because there are errors in this line work somewhere. Now, we haven't actually got time at the moment to go hunting them, but my guess would be round some of these little areas here where we've got smaller buildings in between the larger ones, there's possibly some lines from this one that have got joined onto them when they weren't intended to. When you're working very closely to other shapes, you're going to want to put your snapping on. You can see throughout what we've done so far, I can't bring the 2D one up when the 3D one's on screen, but throughout what we've done so far there's been a little magnet symbol on my toolbar, and that means snap to the nearest piece of geometry. And when you snap to things, if you've got the distance too close to each other, you might draw this but snap to this. So these may become joined on one tiny little joint down here somewhere that you wouldn't otherwise have noticed. The other problem you might have noticed is that all the geometry is solid. So here, for example, this and this are two of the conveyors that used to go across the main road down to the Grove. Now, obviously, you can't drive through them, and what you would actually need to do is to be able to sort of cut a hole under here. Same with the gantries here. The ore gantry that used to feed the back of the blast furnace range. Blast furnace range being here, the gantries being here. They were actually gantries with legs on and gaps in between, from what I've seen in the various photographs and footage that I've got. So you do have things like that. Now, QGIS can go some way to helping you achieve that, because if you look in your 3D settings, you do have some options that you can use. Height, for example, says how high off the ground I want it to be. So if you had all your conveyor belts in a separate layer, for example, and not just all in the one company buildings layer, you could say, right, well, all conveyor belts are 10 metres off the ground and they are 20 metres high. If I apply that, you'll see that the company buildings now move 10 metres off the ground. Now, as good as all of this is, this still is not for the normal layman, the normal person. Somebody who doesn't know how to use this software is not going to fire this software up to look at any 3D models that you may or may not have created. So let's close our 3D map down. We'll go back to our 2D and we'll put these off here, and we'll go back to the temp layer that we created just a little while ago. What you're going to want to do once you've created some of this line work is you're probably going to want to export it. So if we right click on here and we export this file, we're going to save the features as, and we're going to select something called keyhole markup language. Now you'll see that QGIS will allow you to export in a multitude of different formats, and unless you know the different GIS packages and the different things that are going to open these, a lot of these won't make sense to you. KML, on the other hand, you may have heard of before. KML is actually Google Earth format. So we're just going to give this a quick test. We'll drop it on my desktop somewhere, and we'll call this demo model.kml. We'll just save that. I don't want to add it to my map. I've already got it on my map. We'll try putting the feature symbology on, but that doesn't always work. And we do want to clamp it to the ground. Okay, there you go. It'll tell me that I've saved that. If I just go and look down here, there is our demo file. So if I shrink this down a moment and then just fire up Google Earth, I should now be able, let's just let this get itself set up. Let's just bring our map in a little closer. Now if I take that file that I saved from QGIS and just drop it on to Google Earth, we should find, voila, there we go. Because we georeferenced it on our 2D map, these now appear in the absolute real world correct position on Google Earth. Now, as I mentioned just a moment ago, Google Earth doesn't always respect the symbology and the colours that come in from QGIS, so quite often we have to do something like this. So we'll just we'll give it a colour. I don't know. We'll give it this colour here. We'll give it 50% transparency so that we can actually see this. And if we zoom in a bit closer, you'll see, there we go. There are our two buildings and our chimney that we produced using our 2D GIS package, QGIS. Now, a lot of people don't realise that Google Earth can also do 3D. If I press and hold my middle button on my mouse and pull it back, just as I did with the 3D view in QGIS, you'll see that I get a nice 3D view over Consett. And if we have the terrain turned on as well, that's just flat. But if I turn the terrain on, you'll see that we get the hills and things as well. If we go to our demo model and we go to the altitude tab, we saved it clamped to ground, if you recall. But clamped to ground is not the only option we've got. If we go relative to ground and then say 10 meters, we'll see, just like happened with QGIS, our 2D line work hovers above our Google map. But even better, if we go back into our properties and go to altitude and click this here, extend sides to ground, we can now put our 3D objects, our 3D buildings that we've created using QGIS into Google Earth. And because we've got the terrain turned on, as you can see, if we zoom in without the terrain on, that's just flat and boring. But if we put the terrain on, incidentally, Google Earth likes doing things like this, completely changing what you thought you had your settings on. So don't be surprised if something like that happens and knocks you completely out of whack of where you expect to be. There we go. If we zoom back in on this now, you'll see that we've actually got a slope here. So it respects the hills and the shape of the land as well, if you do it properly. Now, I've been telling you through the past sort of 20-25 minutes that yes, we've still got ugly square blobs. How do we get the detail into them? Well, the next step comes from using the package that I mentioned previously, which is SketchUp. Because of the whole Google Earth thing that I mentioned previously, I'm not going to go through exporting this from Google Earth and into SketchUp, because that will take at least another couple of hours. So I've got one that I already prepared. If we just minimize this for a moment, we'll get rid of our demo model. And if we minimize this for a moment and bring SketchUp up, you'll see here's part of one of the older models that I generated. Now, you see we've got a cooling tower and some of the other buildings there. But more importantly, we've got our rectangle here of the building that we were trying to create before. Let's change to a top-down view so that we can see our Google map underneath, and you'll see that this actually has an older version of the same Google Earth map under it as appeared in Google, so you know that this line work is correctly referenced. If I zoom into this line work, now I'm not going to try and match this up because I've got snapping and all sorts on, and it'll snap to the actual underlying map. So I'm just going to quickly put a pretend rectangle in there that represents our building. Now straight away you'll see that that disappears under there, and that's because I've got the terrain switched on as well. So when you're using this kind of methodology here in an application like this, it will respect the terrain also, just like it did before. So you can see if your building's sunk too far into the underlying land and things like that. If we go back to our 3D view, again, drag with the middle mouse button, we can then start using tools like this, for example, and bring our block out of the ground, so to speak. It's still only an ugly block, right? Well, because we've now got it in a package like SketchUp, we can make use of the many things that SketchUp can do. So, for example, if I use the measurement tools and get a line that's exactly across the midpoint. No, I don't want any of that. Stop doing what I don't want you to do, thank you. And then if I select this line, we can actually start doing things like morphing this object. For example, can I get that? There we go. So I can pull that middle line up, and our building now all of a sudden has a roof on it. We can add bits onto the side of this. So if I take another rectangle and I carve that rectangle into the side of that building, and then select just that rectangle and use my pull tool, I can bring that building out. If I select this line on the end and then use my move tool, I can slope that building, give it a bit of a slope and roof. That kind of thing. I don't think that chimney that we had on the other demo is on here, but let's have a look and see if it is, or if there is a chimney we can use. Use the pan tool, move. Yes, there's a. I think that was a chimney. I'm not entirely sure. It's small and circular, so it'll do for the purposes of demonstration. I'm not going to save this one afterwards anyway, because this is one of my older ones. If we take our circle tool and draw a circle there, and then take our pull tool. There we go. And you can see we've added a chimney into the mix. And again, just like with QGIS, and through a lot of work, you can start bringing these 3D objects up out of the ground, and then you can start shaping them to the shape that you want. More importantly, you can also put colours and textures and things on them. So if I select that, for example, we'll give that sort of a red brick colour. Yeah, and we can give that roof a colour like this. You know, we can, or we don't have to use colours. We can actually use images. I don't have any images available, so I'm not going to, but instead of putting a colour on there, if you had a photograph, so let's just spin this round for a moment. If you imagine that back when this building actually existed, if you'd sort of stood somewhere here and took a photograph flat on of that side, and you had a good quality photograph of the side of that building, that photograph can then be cut out and that could be put on there, so that that ugly square then looks like the actual building used to look. And this is how I've in the past done the models that we've already had on Google Earth. Now if I export this as a 3D model, we'll just demo that. Now we notice this time that it's a KMZ, not a KML, as the other one was. There's a difference because KMZ wraps all of the colours, all of the images, this map image, all the line work and everything up into a compressed file. A KML is just one set of line work. KMZ is a whole folder of different files that are used to make the model up. The end result, however, is that we now have, yet again, another Google Earth file, and if I drag that onto our Google Earth, there's our building. Complete with its detail and its shapes and stuff, and you can see that it now has roofs and colours and things like that. Our chimneys there, you know, we could have put a brick pattern on that so it looked like a brick chimney, and the bits and pieces that were already in the file are there too. And that's the basics of using the free software. Once you've got a correctly geo-referenced map and you put the geo-referencing into QGIS and you geo-reference and geolocate your maps properly, then you take the map and you produce the 2D line work. Then from the 2D line work you bring that into a package such as SketchUp or some other 3D package, there are many of them, and you add the detail to those square boxes, and then the square boxes are saved back out into a format suitable to then be loaded into Google Earth. And the net result is, let me just find my folder with the other ones in. Give me 1 second, because I do appear to have closed it. I thought I hadn't, but I have, so I'm just going to have to browse to that again. I have far too many files and things on this machine. And that means we now end up with models such as this one. So this is the one that many of you have probably seen from my photographs on my Flickr page, if you've actually looked at it. And you can see that I've taken just a generic brick pattern and applied it to a brick wall. A generic slate roof pattern, applied it to there. Sheet metal and applied it to the side of those buildings. You know, these buildings here have got brick walls with windows in them. You know, I don't exactly know what was there because, as I've mentioned previously, I didn't know any of this in that amount of detail. You know, so if anybody has photographs that we can use to put onto the side of these buildings, please do scan them into the computer, because the more photographs we get of these structures and what they looked like, particularly if they are good flat photographs taken that take the whole building in standing next to the building, they can be put on these models. The 2D line work can be put into a shared database so that lots of other people can help. You know, there's still a lot of work to do here. So if you're interested in drawing maps, please get in touch with the group and I'll set you up. We'll teach you how to do this and we'll get you up and running to start adding your own bits and pieces to these maps. You'll see, for example, here, if I bring number 2 plant in, number 2 plant is still an ugly grey blob. But based on photographs that I've got showing the plant from Black Hill, I know that there was a lot of pipe work on the end and round here. I think it was one of Matthew, whatever his second name is, as photographs taken from the site where Black Hill Station used to be. So I've modelled these pipes and things in, but I have no idea what colours they used to be. I have no idea whether that was brick, whether it was sheet metal, or anything like that. We have the tin mill still to do as well. Calm down. I've done some of the tin mill by the looks of it. Again, that's a brick pattern. That brick pattern is based on photographs that I've seen of the tin mill and what I know of the tin mill. You know, obviously I've got a couple of errors there, so I really need to have a look and see why that's sat on top of there. Well, it shouldn't be, that's a bit strange. But again, there is a lot of work still to do. And then ultimately, once we've produced these models and once we've done the 2D line work, we then want to start looking at modelling the landscape. So for the last 10 minutes, I'm just going to quickly show you another application. Now, this application is called Global Mapper, and this unfortunately is a paid product and it is quite expensive. But if you can afford to get a copy, and with the help of DEFRA, we can get hold of imagery like this. Now, for those of you who've never seen this before, this is called a LiDAR map. Basically, it's a very modern thing, so we don't unfortunately have landscape data of this quality going back to the period when the works were still there. If we can get hold of data, such as from land surveys and points on the ground showing the land heights and the work that was done and what was re-landscaped and where, we can use this application to rebuild that landscape. And I'll show you what I mean in just a second. One of the benefits of being able to use LiDAR, however, is being able to spot things that you wouldn't normally otherwise notice. There are a lot of details down on the ground that still exist, that still show scars on the landscape of where certain bits of the works were and things like that, that unless you've got a drone taking aerial photography, or unless you've got access to something like this, you might walk over or walk past 100 times a day and never realise that they're there. If I zoom in, for example, this area here is where the steelworks used to be. So we'll just bring this in a little closer. And you can already begin to see, as I start to zoom in, just at the extent of which this area has been changed. But more importantly, the reason I've zoomed in on this area, you can see that the outline of the slag heaps is still there. Now, any of you who've seen photographs of the company taken from Castleside or taken from the Grove will know these huge lumen slag heaps that sit above. Because they've been smoothed out somewhat slightly these days, you don't really see the shape of quick Google Earth. But if I was to go back to Google Earth, all you would see is just sort of a fairly gentle green slope that goes down there now. But you can see the outline of them are still there. Some of it's been cut back, obviously, but the vast majority of it's still there. More importantly, you can see where the old Grove Road used to run. Just here. The road that went down to the Grove came up through here and up to Bury Edge. You can see the edge of the landscape where Low Yard used to be. And if you look carefully, you can see the scars on the land, where everything has been pulled up, where the tracks, where all the land's been levelled. You know, you can see this edge here that's been dug out, where Consett, I think it was Consett North Signal Box used to be round about there. But if we zoom in a bit closer, you'll see that this embankment here is quite rubbly. Well, that was where the bridge used to go over all the railway lines at the Grove. And a lot of that rubble there, even though you can't see it because it's got soil and grass growing over the top of it, a lot of that is the brick rubble underneath where the bridge was pulled down. And if you keep looking and keep examining the landscapes, you see other scars as well, sort of such as this one here. You know, you can see that that's not a natural scar. Here, where the new road was built round the edge of Templetown, you can see where this has been cut down and re-landscaped. You can actually see that the edge ran round there, and if you were to draw a line that followed that curve, you'd see that it would match that curve absolutely perfectly, and you would be able to put this hillside back in. Things like the Canyon Road. Those of you may have seen the post that I put in the Steelworks group yesterday with the remaining part of the Canyon Road that's left. Well, if we go over to here, without the help of any of the 2D maps, we can see straight away there is a scar right across the landscape there where the Canyon Road used to run. And more importantly, I live on this new estate round here. The estate behind us, up on, I forget what it's called now, coming off Saxon Terrace here, that is up on quite a high bit of land. Yeah? And if we go back and look at that in the 2D map, you can actually see why that high bit of land exists. Because the entrance road going down and into the company, the Canyon Road, had this large embankment on one side of it. It had this smaller embankment on the other that curved round with the two cooling towers on top of a sort of slightly sunken depression here. The thicker part of the line at the top tells me where the top of the slope is. And we can actually pick that out on here. We can see where this bit of land here where the cooling towers used to stand has been dug out, but we can see that that far embankment there still remains, and we can see roughly where that used to go straight down and into that part of the works, and the other part of the road used to curve round and come down to the company offices, which were roughly about here. One more interesting one that I'll show you just before we go is the old pit at Delves. Let me just get my bearings here. There's Delves roundabout. Now we all know that Lidl's been built there now, but some of you older folk may actually remember that there is an old World War concrete bunker under the edge of that embankment. Well, there you go. You can see the big flat concrete slab that is the bunker. I believe it's long since sealed up now, but you can see it there. Another thing, some of the younger viewers might not realise, there used to be a railway bridge there at Delves, and you can clearly see where the edge of the bridge was on that side, but where it's all been filled in and landscaped on that side for what used to be the Delves Club and Bescol Motors and Keith Morton's Garage and such like. This heap here, this is all built of rubble from the brickworks when they pulled the brickworks down. Things like that. The old black path that used to go from Delves all the way across to Templetown. They may have built over this part here where the road is, but you can see there is still a large chunk of it there. But walking down that path today, you would not realise that that was part of something historic. And with tools like this, with tools such as Global Mapper, we can analyse all this. We can decide what we need to digitise, where we need to digitise it, how we need to digitise it, how high it needs to be, how far off the landscape it needs to be, and we can tweak all of these settings in QGIS. We can set the building heights, we can set the 3D, and then we can export them into Google Earth, and we can give them to the rest of the world to play with. And that is basically all I have for you guys for now, I'm afraid. As much as I'd like to go into this in more detail, the detail would take me considerably longer. I do believe that when all this coronavirus stuff and that eases up some more, we are planning on looking at the possibility of getting together in maybe a hall somewhere and possibly running a workshop, or possibly going through some tutorials for this, which I'll be more than happy to help people with. Feel free to come into the History of Consett Steelworks group and ask me any questions that you've got. I can see that there are some chats over here. Yep, I think that's Richard. The History of Consett Steelworks has actually put something into the chat there. So go and have a look at the chat box. That chat will be recorded along with this, and I will leave this up on my YouTube page, so anybody who didn't see it live now can come back and watch it at a later date. I'm also going to give the Consett Steelworks group permission to embed this in their blog if they so wish to, that kind of thing. And I'm going to continue putting various posts and that in the group with different photos and that I've got, and explanations, and showing some of the mapped areas behind them and some of the things that I certainly have learned over the years. So I hope you've enjoyed what I've presented here this afternoon. Once again, thank you to Consett Steelworks, thank you to the various groups, the Consett District Heritage Initiative and Brian and Project Genesis and all that for inviting me along to do this, and hope to speak to you again at some time again in the future.